Hi, my name is Cengizhan, and I am going to show you the visualization that Diederik and I made for the visualization course at the TUE. Our chosen dataset is the complete Pokémon dataset, on which we use visualization techniques to draw interesting conclusions about certain species of Pokémon. So let's start with what we see at the top. At the top we have our filter view. Here we can filter out different Pokémon based on their attributes. So let's say for example that we're only interested in Pokémon that are classified as legendary. Then we simply uncheck the non-legendary checkbox to leave out the non-legendary Pokémon. As you can see, our filtered dataset results into an output of 70 Pokémon, which you can see right over here. Our filters effect have visualizations down here as well. So let's go ahead and collapse our filters. So let me go ahead and show you our list view. And let me zoom in as well. So we use our dataset to generate a table with the attributes of each Pokémon with respect to the chosen filters. Our table is sorted from the lowest to highest Pokédex number, and additionally we included some icons to make the rows more identifiable. Our table is sortable and searchable. A user can use the search box to find a Pokémon by searching for its name. By clicking on the column titles, we can sort by the values in that column. An additional click will sort it in reverse order as well. If a user would want to get a bit more insight into some statistics of a Pokémon, they can simply use the highlight view. The way a Pokémon can be selected to be put in the highlight view is by clicking on the row of desired Pokémon in the list view. Let's use the legendary Pokémon with the highest special attack stats, for example. This view generates a more detailed overview, showing the defense attributes of a Pokémon and a radar chart that shows the spread of its statistics. Let's take a look at our scatterplot matrix. Each scatterplot in our matrix is constructed from two numeric variables. We can choose up to 4 different variables to compare. The chosen statistics names are then being shown on the axes. In our example, we set our initial variables to the HP, attack, defense and speed values of the Pokémon. We can then hover over the data points to see a small overview of the data from that data point. The colors of these data points are based on the primary types of the Pokémon. To make it easier to analyze this data, we added a couple of techniques. Firstly, we can use brushing on the scatterplot matrix. The brush window can be moved and resized as well. Secondly, hovering over the rows of the Pokémon in our list view grays out all the data points except the Pokémon we hover on and the Pokémon that we have highlighted. Finally, we have a button that hides all data points except the highlighted Pokémon. If we add more highlighted Pokémon, they show up in this view as well. Let's go ahead and change our filters and collapse our scatterplot matrix. Let's look at the density bar chart. This chart shows the distribution of data over continuous intervals. We can choose various stats to plot and group them either by generation or primary types. As an example, let's look at the special attack of Pokémon by their primary types. From the density bar chart, we can then see that normal Pokémon from a filtered set generally have low special attack stats. Finally, let's take a look at the heat map, which represents individual values as colors. The heat map shows the lowest to highest values from bright to dark blue respectively. In this visualization, we can choose between the generation or primary type of Pokémon as our y-axis variable. On our x-axis, we have the stats of the Pokémon. For the heat map calculation method, we can choose between the following options: minimum, average and maximum, while also taking the chosen filters into account. For example, we can see that the maximum HP value of a normal type Pokémon can be 255, which is much higher compared to other types. This concludes our screencast of the information visualization and interaction exercise for the visualization course at TUE. Thank you for your attention and have a nice day.